All right, so number 2 is asking us the range rule of thumb for interpreting. It says the 20 brain values in centimeters cubed for data set 8, IQ and brain size appendix B, have a mean of 1,126 centimeters cubed and a standard deviation of 124.9 centimeters cubed. It says use the range rule of thumb to identify the limits separating values that are significantly low from significantly high. Now, unfortunately, this book likes to use this rule of thumb definition. Well, they like to use the words, but they use it in different ways. So in this case, what they're asking you to find is the usual values. They want to know what separates, too small from too large. So I'll slide this over. Let's start doing some work here. So what I know is I know the mean is, we have a mean, so x bar is equal to 1126.0 centimeters cubed. I'm just writing the units in there just so on a test we don't forget to do that, right? And then I know that the standard deviation, which we call S, is going to be equal to 124.9 centimeters cubed. So we want to find like the usual values. Basically separating the min and the max. The minimum value and the maximum value are found by using, your mean and your standard deviation. So for the minimum, you take your mean and subtract how many standard deviations? 2 standard deviations, so 2s. And then for your max, you take your mean and then you add 2 standard deviations. We're going to do this so much, okay? This is going to be so very complicated for everything. On a test, I'm going to ask this multiple times. So x bar, we got that 1126.0. It's nice I recorded. Look at that mess. All right, so plus, minus 124.2. I'm breaking it up here. Okay, so 1126.0 plus, I forgot my 2 too. Pressure's getting to me. So 2 times 124.9. Okay, so we just pop them in our calculator and we let it go. So 1126 minus 2 times 124.6, 9. So what I like to do is, I know that I'm going to use this a lot. You can close your parentheses, you not close it. So since we're going to have to find the min and the max always, I usually just hit the enter button to find the min. And then if you hit second and enter again, it'll actually put the exact same equation in there. And I'm just going to take that minus sign and turn it into a plus sign, just so I don't have to type as much. Because every time you type in, you have the chance of, putting the wrong number in there, right? I better make sure that I got them right. All right, looks good. Okay, and enter. So those are your mins and max values. Don't forget the units, right? Now, remember that these values are already rounded. So when you write them, you're going to basically use the exact same numbers. So remember that, I need to be sure, because when we round data, we always round 1 decimal past the given data, right? So when I find the mean and I find the standard deviation, I know that those are already rounded 1 decimal past the given data. So when you give all your units, it's always going to be 1 decimal past the given data. I know we don't see the data, but we already know it's been rounded. So these things are going to be rounded to the same decimal that these are. So I have 876.2 centimeters cubed to 1375.8 centimeters cubed. So these are your usual values for brains. So if I bet you if well, let's talk about usual values. Not to be gruesome here, but if we measure the weights of all our brains in this class, it's supposed to say how much, what's the percentage of brains that live between those? 95, yeah, 95%. Yeah, but it's 95%. So if you look at that bell-shaped curve, essentially, because brains and a lot of things have that normal distribution. I know that they should be bars like our histograms, but when we get to continuous data, it'll actually look like this.
Isn't it like 36.2 on like the middle, like towards the mean, and then goes to like 12 to 40?
Yeah, and what I want you guys to know is just what this lives between. You don't have to find the areas in between each one of these. I only want you to know that in between 2 standard deviations, which is important, x bar minus 2s to x bar plus 2s. This would be x bar plus 1s, this would be x bar minus 1s. But this data right here are your usual values, and 95% of all data lives in there. So if we have 20 people in this class, 19 of them will be in there. Does that make sense? Cool. Number 4. I'm going to try to clean that up. Not any better. Hold on. Identify the symbols used in each of the following: sample standard deviation, population standard deviation, sample variance, and population variance. Oh, I got the answers right there. I know them though, I promise. Okay, so when it comes to variation, we know that we have two different forms of variation. You have a standard deviation, which tends to be what we use more often because the standard deviation has the exact same units. But the variance is also used for variation, but the units end up being the units squared. Because your standard deviation, so for your sample, and then your population, start it up. For your standard deviation, and then your variance. The sample is S, and the population for variance would be S squared. So for your sample, the standard deviation S, for variance it's S squared. Now your population for standard deviation is given this sigma symbol. Looks like an O with a really cool hairdo. And this one would be sigma squared. Is that clear? So the variance is just the square of the standard deviation. So if we had the variance, we had the standard deviation here. If I wanted to find the variance, I just square this number. But if I square this number, I'm also squaring this number as well, okay? So that's why we don't like variance as much, because the units aren't the same as the data. You can't find that, it's not as easy to find these numbers here. You'd have to square root it to get back to the standard deviation. Number 17. Oh no. Can we pick a smaller one? Because this is asking probably to find the standard deviation, isn't it? All right. How much time we got? Not a lot.
Just ask if there's any outliers.
I gotcha.
And I still found it.
Yeah, so tell you what, I want to do an example for standard deviation just so you have something to do, but I'm not doing that many data points. It's going to take me 15 minutes to do, okay? So let's do it like number 8. But we'll find that with the calculator. We'll find that with the calculator because it'd be good to show everybody how to use the calculator again, because it's what we're going to eventually do later. But what I want to do is I want to do the exact same question they're asking. So in this section, they're asking find the range, the variance, and the standard deviation. And you know what? We're going to find the usual values as well, because we might as well. Because in order to find the standard deviation, you have to find the mean. So we'll do it for number 8. I'm doing it for number 8 because there's not a lot of data points, so it's not going to take me forever. It's still going to be kind of forever, but not forever. All right. I can't believe I'm recording my voice. This is going to be terrible when I go back and listen. All right, so I got 212, 77, 121, 104, 153, 264, 195, and bless you, 244. Okay, so these are our data points. Now I'm just going to project the image of standard deviation, how you find it, somewhere in here. So since this is a sample, we're using this one right here, sample standard deviation. The difference between calculated a sample standard deviation, which is what you guys are going to have to calculate on a test, as opposed to a population standard deviation, is the sample has n-1, but the population just has n, right? Okay. But we're always going to calculate a sample in this class. So that's the equation we're going to use. So let's start out with the range, because that's really straightforward. So the range is the max minus the min. So what we have to do is we're going to have to find the maximum value, we're going to have to find the minimum value. So the max value is what?
264.
So this is 264 minus 77. Yep, that's all right. I have a hard time looking at them too, so I usually have to go back. So 264 minus 77. So I get 187. Don't forget the units. What are the units? That's a good question. What are we talking about here? Oh, this is dollars. Okay, so I'm just going to write dollars here. Dollars. All right, so the next we're going to have to find the standard deviation. Let's see. It says find the variance and standard deviation, but the variance is found by finding the standard deviation. So I'm just going to go through finding the standard deviation, and I'm going to identify what part of that is the variance, okay? The second to the last step is the variance. So when you want to find a standard deviation, you know that S is equal to the square root of the summation of x minus x bar. Make sure I get that one right. X minus x bar squared, all divided by n minus 1. So what we're going to do is we're going to do each one of these steps in order. So I'm going to kind of work inside out. So first I'm going to have to find that x bar. So step 1. X bar is the sum of the data, right? So you're going to go 212 plus 77 plus 121 plus 104, 153 plus 264 plus 195 plus 244 divided by 1, 2, 3, 4, 5, 6, 7, 8 of these. And we're going to try to take our time plugging them in so we don't mess them up. I got 1370. Anybody doing this with me? Okay. Divided by 8 is, I got 171.25. This is good because remember, when I go to 171.25, and we know that this is also going to be in dollars, but before I write the units, I need to talk about the, if I was asking on a test, we're going to use this number when we're calculating the rest of it because I don't want to round in the middle of calculating something. But if I ask you a little bit later, which I will, like what's the mean, what do you round this number to? Yeah, because if you look at the data, it's in ones, right? So you always get to go one decimal beyond the data, so just one further. But we're going to use this for right now, okay? So I'm going to write the mean and everything. I'll list everything at the very end. Okay, 2. So what we've done so far is we've done x bar. That part's been done. X bar has been done. Now we have to do what? X minus x bar. So we're basically just working this equation inside out. So I need x minus x bar. Unfortunately, how many data values are there?
8.
So how many of these are there going to be?
8.
So we're going to have to list 8 of them. So I'm going to have, so 212 minus 171.25. I have the 77 minus 171.25, and then so on, right? Yeah, it's messy. I'm going to run out of room. Should have picked the smaller one, right? I would have preferred that all to be on the same line. So when I calculate it and try to get all the answers, I'm going to try to fit them on the same line so it doesn't get ugly. I promise on a test, I will not give you more than 5 or 6. Okay, 6 is usually the biggest number because it just takes forever. So I don't like to have to type in. That's like 6 keystrokes, right? So what I can do is I can take this, I can hit store, and I can store to X, and then hit enter. X is this button right here. And now I'm just going to go 212 minus X and hit enter. And I'm going to go 77 minus X and I'm going to hit enter. And it's just going to go quicker, okay? Anything to try to reduce the time it takes. This is the only test I'm going to make you do this by hand. What we're going to do next is we're going to we'll do it with a calculator just to make sure that we get the right answer. Somebody doing this with me?
Yes.
Thank you. So if you see any errors, let me know. I appreciate it. So I don't like doing this many data points because error can come in just by fat fingering something. Okay. Does everybody have those same numbers? Okay, so let's assume they're right. Next, what do you do with them? Square them. So now we're going to square these things. Back up here, I'm going to square those things. So 3, we have x minus x bar squared. So I'm going to square all those numbers. What's nice is all those numbers right now, I have some negatives and positives, right? Turn that up. When you square them, all those negatives are going to turn into what? And all the positives are going to turn into? Positives, yeah. So they're all going to turn into positive numbers. So 40.75 squared. So, you know, if you already had that 40.75, you might want to do this step and the next step at the same time. Does that make sense that you could calculate those numbers? But I'm trying to do step by step by step because it really helps students to try to stay organized. So this is kind of a bigger number, but I'm going to go all the way, I'm going to go to 4 decimal places. But if it's really, really long, I'm going to stop at 4 decimal places because I know that's going to take into account any rounding errors. I know at the end of the day, we're going to round 1 decimal past the given data, so we're going to round to the tenths place. So I'm going to take it to 4 decimal places just to make sure there's no rounding errors at the very end. But again, if it's got like 9, don't do 9. Just go to 4. It's usually enough. Wow, these numbers are getting big. 555.2.5625. Okay, that's there. So. So I'm kind of hoping you guys all have the same numbers that I do. So I was trying to keep them all on one line. Unfortunately, I just run out of room because the numbers got large. What's nice is, you know, these are all 8 data points, right? But what's next? Yeah, and when you sum everything, these 8 are going to spit out what? 1 output. Thank goodness. So now it's just going to be 1 output from now on, all right? So all the mess is going to go away. So 4. So that means I have to add these. So this is going to be the summation. Summation of x minus x squared. I wonder, like, if we were going to see these things flying around. And then, okay, so we're going to add these numbers up. I'm going to do a dot, 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 because I don't really want to write all the numbers again, but I'm going to take that, you know, that 1660.5625. I'm going to add the 8883.0625. Add the next one, 2525.0625, plus, and so on until I get to that very last number. So remember, there's going to be 8 here. I'm just writing a dot, dot, dot because I'm lazy. So 5625. Now, if we have this right, if you look at your calculator, if you have this right, you have all these previous data points in there, right? You see that? So what we can go to is I can let's see if it'll let me do it. I can go this plus, it's that's maybe. Let's go all the way to, that was the 40, this plus, you're welcome to type them in by hand as well. This plus And what I'm going to do, because I know there's 8 data points, and I don't know if I messed that up or not, I'm going to go back and I'm going to count these. So there's 1, there's 2, 3, 4, 5, 7, 8. Okay, I think it looks good. We're going to hit enter, and we're going to kind of cross our fingers, and I hope everybody got that ridiculously large number. Everybody got that thing? So this is equal to 1009333.5. Cool. Next. Yep, you have to do over n minus 1.
I didn't.
No? Did anybody else not get that number? No? Not you either? Okay, well, let me type them in.
I think you mistakenly put another 9 with the 92.75 when you squared them.
Did you get something around 13?
Yes.
Thank you.
Okay, what did I mess up? So I'm going to go back to you guys because you have the answers as well. You guys get the 1660 for number step 3? This number?
1660.
All of that's right.
All this is good?
Yeah.
Okay.
I got 32,000.
But when you added them, you got a much different number?
Yeah.
Okay, let me just type it back in. So, do you see why I'm not going to make you guys do this many of them on a test? Because this would be the only question.
So how many like on the test we have to do by hand?
Only one. I'm only going to ask you guys to do this once. And it's going to be like 5 data points, okay?
Yeah, because I was doing the homework and like I did a couple by hand. I'm like, should I just keep doing it by hand or should I
Just do a couple. Make sure you can do it, okay?
Yeah.
It's fine by me. I just want to make sure you can do it on a test. Dang, still got that. I don't want to go through it again. All right, so is it this one right here? That's too big?
Yeah.
Okay, so I have an extra 5 in there?
When I did that, I get like 8,602.562.
Yeah, because that number seems suspect, doesn't it?
Yeah.
Okay, so what'd you get for that one?
8,602.5625.
Okay, let me clean that up then. I'll put that in there. Oh, I see it. Yeah, I got 900 and yeah, okay, I got you. I squared 900. Nice. All right, so enter. See if I can't save the day. God, that's a big number. I should have noticed that. So you got 8602. Point. Cool. Okay. What'd you get for an answer? What's the numbers, guys?
32,383.5.
1,000 what?
383.5.
383.5. Did everybody else get that?
Yep.
Awesome. Good. So now that we've got that number, next what we have to do is what? That's right. So now I have to go over n minus 1. So this is the sum of x minus x bar squared all over n minus 1. So n was what? 8. So this is at 32383.5 all over. Well, since n is 8, this denominator is going to be what? 7.
Ooh. We're getting somewhere now.
Finally. Holy smokes. All right. So I knew today was going to be a lot because it always takes time. It always takes time. So I'm going to write it out for a little bit. Number 6, what do you do next? Finally square root the done thing. So now we're done. Summation of x minus x bar squared all over n minus 1. So last I'm just going to square root that number, that 4626.214. To be honest, if you went to 4 decimal places, it would probably be just fine. But since I wrote it, I'm just going to write it down. So second square roots. So usually what I do is second square root, I'll go up and I'll press enter. Square root that way, so I don't do any rounding. So I got 68.01. You guys get that?
Yeah, because
02, yeah. Well, 01, 6, 2, 7, and 9, 5, 7. When you round, we always round to 1 decimal past the given data. Is that agreed? So our data was in whole numbers. Yeah, so we're gonna go to where? That one, right? So it's just gonna be 68.0, but 68.0 is the same as what? So you're welcome to drop off the zeros on the end. So this would be in dollars. Now let's talk about the variance. Remember the variance and the standard deviations are squares or square roots of each other depending on what you have?
Right.
So if I square this number, what do you think you're going to get?
Variation.
This thing right here, the one right above it. Does that make sense? So if you just take that number, if I take that number and I square it,
Yep.
I get that previous number above. So if you want to know what the variance is, it's that number in step 5. Except this will be dollars squared. So if you wanted to find the variance, I'm going to round now, not before I find the standard deviation. Before 626.2, this would be dollars squared, whatever that means. Okay? Does that make sense?
Don't you wish you get paid that way?
That would be
Dollars
nice.
squared?
That'd be great.
Oh, yeah.
And start now.
Anytime.
Okay, so now that we have the standard deviation and the mean, how do you find the usual values again?
X minus 2s and then x plus b.
Yeah, so that rule of thumb.
95%.
Yeah, let's look at the 95%. Let's see whatever we're talking about here for this example. But so that means the usual values will be x bar minus 2s to x bar plus 2s. X bar, when we looked at it up here, it would be 171.3. You guys agree?
Yeah.
Okay, so this would be equal to $171.3. Has the same units. I'm going to round now because that's what we round the mean to. Technically, when you do the calculations, you shouldn't do any rounding for these things, but I won't mark you wrong if you use the rounded numbers for these, all right? Because I'm going to ask you what these values are on a test, and you're probably going to go back to look at those values to use them. So if you're off by a very little bit, it's probably because of some rounding error. So minus 2 times that 68.0, I didn't need the other 0.0, and then the other one is going to be 171.3 plus 2 times that 68.0. So our 95% lives in here. So I got 35.3 to $307.3. Don't forget your units, right? 'Cause I'll mark you wrong on test. Not wrong, but I'll take off a points. I'll do it for like maybe up to test if you know what you're doing. All right. Let me stop this. Actually, let's finish this one more thing I wanted to show you guys. Finding that's a nightmare. Everybody agrees. Is there a way to check your answer? We're gonna do it on the calculator. We're gonna put those data points in the calculator. I just want to make sure you guys know how to use this, and then we'll take a break. All right. So, on a calculator, what we're gonna do is just gonna plug in those numbers, but we have to put them into stat. So there's a button that says stat right there. So press that button. And what I want to do is I want to edit. So it was already at that edit menu. So I'm gonna go back so you guys can see that again. You hit the stats. Notice that the edit is highlighted. So hit enter, and then you're going to be able to put your data set in. You can go up here and hit clear, but do not hit delete, because if you hit delete, that L1 is gone. You'll have to insert it and put it back in. So say you accidentally delete it. See how L1 disappeared? So to fix that, you go second insert, and it'll put that column back. But you have to use this L1 right here. See, it's the blue above the number 1. So you have to hit second 1, and then put your L1 back, okay? So instead of hitting delete, hit clear, and then enter, and it'll get rid of those data points. Or you can just type over top of them for all I care. So 212, enter, 77, 121, and then so on. Okay. 1, 2, 3, 4, 5, 6, 7, 8. And then I would just double check them, make sure that you put them in right, which tends to be where errors happen. You guys could tell I inputted one wrong on my previous one right here, right? It's easy to do. Okay, so now what I want to do is I want to do some calculations on this. So I'm going to hit the stat button again, and add it. I'm going to go to the calculate, so press over once. And then this is one variable stats. It's one variable because we only have a list of numbers, right? One list. So I'm going to go enter, and L1 is the list that it's in, and then I'm just going to go on the calculate and hit enter. So it gives me a mean, which is what we had before. It gives me a standard deviation, which is exactly what we calculated, right? And so on. Right. This is how we're going to do this after this chapter, okay? We're just always going to type them in and do it this way because it's quick. More of this class is going to be about interpreting data instead of always calculating it.